Okay, so the unit circle, let's talk a little bit about this. So this is the unit circle, and this is used a ton in trigonometry and different things. So the unit circle is, you use it in a lot of professions today. It's seen in architecture, engineering, geography, astronomy, digital imaging. It's used to estimate heights and distances. That's just a lot of trigonometry is used to estimate that stuff. Trig functions are used in studying light, sound, and electricity waves, and then spherical trigonometry. So a sphere is just a circle, but like a three-dimensional circle. Okay, so just to kind of give this like some background, it's kind of cool to know like where does this actually come from? Like why do we even use it? So in architecture, it's used to determine like geographic or geometric patterns, curving surfaces, finding heights, and etc. Astronomy, which like I love astronomy. I think astronomy is so cool. The Babylonians, Egyptians, and Greeks. So think back to like when the Babylonians, the Egyptians, and Greeks were even around. I mean, they're still around, but like these times, that's a long time ago. They used trig to identify and organize stars because you can determine a lot of things by just looking at the stars. The Babylonians used trigs to give coordinates to the stars. The elliptic circle is what the trig is based around. And astronomy was one of the first to use trig functions, which is super cool. So let's fill out this unit circle. And I want to do this without memorization. There's tons of tricks to memorize this. And I'm going to put that on you. If you want to learn the tricks, you can go do it by yourself. Okay? I want to teach you how to do this with like special right triangles and things that we've already been going through. There was a copy of this on the Canvas page. So if you have a printer, I would print it out. If not, I would pause the video right here so that you can draw this out and do it. Okay, so let's think, like, what is the unit circle? Well, let's look just at a coordinate plane. In a coordinate plane, you can draw a circle here, just right, that goes along all the ones. Okay, it's a circle with a radius of 1. That's a unit circle, because unit is another, like, synonym for 1. Okay, so that is what the unit circle is if we take this quadrant and you just zoom into 1 and there's a circle right there. Okay, let's fill out the degrees on this. So all the way around the circle, if you walk an entire way around the circle, you go 360 degrees. Okay, well, half of 360, so that's 0 and 360 right there. Half of 360 is 180, so that has to be 180. And then this upward vertical line, that's half of 180. Well, half of 180 is 90. Okay, so if we go 0, and then up to the top is 90, and then all the way to the flat line is 180, and then you go another 90 degrees, that's going to be 270 right there. Okay, then we can do our 45 degrees. I need to like draw probably. So 45 is about... so between these two, halfway between it is right there. So that is going to be our 45 degrees. And then we can just add 45. So 45 plus 45 is 90. 90 plus 45 is 135. 135 plus 45 is 180. 180 plus 45 is 225. Plus 45 is 270. Plus 45 is 315. Okay. And then the last one is we're just going to add 30 to get the rest of these. So it's going to be 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and then 360. Okay? Now let's do our radians. So radians, if you think about, first, what is a radian? So let's get into what is a radian. Let's watch this quick video right here. If I can click it.
Start with a circle of radius r. We take that radius distance and wrap it around the circle. The angle formed by that radius distance is 1 radian. Since the circumference of a circle is 2 pi r, there should be 2 pi radiuses in a circle. So halfway around the circle, we would expect 1 pi radian, and around the entire circle, we would expect 2 pi radians.
Okay, so again, what he was just saying, and I linked that YouTube video onto the Canvas page, but basically if you take a circle, we have some circle, and then we have a radius here. Let's change colors. So the radius is from the center to an outer point, so this right here would be the radius. Well, if we took that and we just took that length and we laid it out on the outer edge of the circle, this distance right here is 1 radian. Okay, so these two lengths are the same, and that angle between them is the radian. So 1 radian is the same distance as your radius, which makes sense why it's called radian. Okay, so let's fill out the radians now. So first, wait, I have to go back. Okay, so 0 goes with 0. If you think about the circumference of a circle, so circumference is the distance around. Circumference, I don't think I spelled that right. Circumference, I did this in class too. How embarrassing. Okay, circumference is the distance around a circle. So, and the formula for that is 2 pi times r. Well, r in this case is 1, so it's 2 pi times 1, which means that the distance around the circle is 2 pi, which is where we get that 2 pi right there. Okay, and 0 obviously goes with 0. Now, half of 2 pi would be pi, so that means that 180 is pi. And then half of pi would be pi half, so that means 90 is pi halves. So to get what 270 is, let's just add 1/2. So if we think about this, so this is 0, this is pi halves, which corresponds with 1/2. This is 2 pi halves, or 2 halves, which means this would be 3 halves. And this would be 4 halves, which 2 halves is the same as 1. 3 halves, that means that this right here is 3 pi halves. Okay, then let's do the 45. So half of a half is a fourth. So that's a fourth. And then if we add a fourth, you have 0, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, blah, 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 so on. So again, here's 1/4. This would be 2/4. This would be 3/4. This would be 4/4. This would be 5/4, 6/4, 7/4, and 8/4. And notice we already have some values on some of those, and that's because those fractions reduce, and we already found them. Okay, so then that means that this is 3 pi fourths, 225 would be 5 pi fourths, and 315 would be 7 pi fourths. Okay, and then we can do a third, because a third of 180 is 60, so that means that 60 is a third. We can count by thirds, so 0, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. And again, we just have to go that same distance. So if this is 1/3, this would be 2/3, this would be 3/3, this would be 4/3, 5/3, and 6/3. Okay, and we can fill those out. So that's going to be 120 is 2 pi thirds, 240 is 4 pi thirds, and 300 is 5 pi thirds. Okay, and the last one, 30 is a sixth of 180, so that's going to be pi 6. We can count by 6, and notice we have a ton of these. We're going to have a ton repeating that we don't even have to really write down again. So this would be 1/6, 2/6 we already have, 3/6 we already have, 4/6 we already have. So this is 5/6, we don't have that one. 6/6 we already have, 7/6 don't have that one, 8/6 already have, 9/6 already have, 10/6 already have, 11/6 don't have it, 12/6 already have it. Okay, so this is going to be, wait a second, 150 is 5 pi 6, 210 is 7 pi 6, and 330 is 11 pi 6. Okay, So that's how you get all the degrees and how you get all the radians. The other thing you could do is take your degree measure and just convert it into radians, and then that will give you all those same values also. Okay, and remember to do that, like say we wanted to convert 135 to radians, I would multiply by pi over 180, which gives you 135 pi divided by 180, which reduces to 3 pi over 4. Okay? Because 45 goes into 135 3 times, 45 goes into 180 4 times. Now let's find the points on the x and y axis, because these are easy points. So let's look back to this. Well, we can see here that this point is 1, 0. That's negative 1, 0. That's positive 0, 1. And that's negative 0, 1. 0, negative 1. Sorry. So those points correspond to these points right here. Okay. So this is going to be 1, 0, which means this is negative 1, 0. And that's 0, 1. And this is 0, negative 1. Okay. Now remember, this right here is important to write down. So the x value is cosine, the y value is sine. And a little stupid thing to remember it is, why would you sin? Because it's bad, so don't do it. Why would you sin? And then you could say, because of my x. Okay, everyone uses their x as like a scapegoat. Like, well, why'd you do that? Well, it was because my x. So that's just a stupid way to remember it. But like, why would you sin? Because of my x. Okay. So do you remember these triangles? Hopefully we did these when we were still back in school. That's what we're going to use here. So first we're going to look at 30 degrees, and I'm going to drop that down and create a triangle right here. Okay, if you have different colors, this would be a great time to plot your colors. So that's a right angle. This is 30 degrees, that's 60 degrees. If we look at this triangle here, right here, whoops, this one right here, we can match their corresponding. So opposite of 30 is x, opposite of 60 is x squared, to 3, and the hypotenuse is 2x. And if I know that the x value is cosine, and I'm using that angle, so cosine, we have to use SOHCAHTOA. So we can label our sides opposite, adjacent, and hypotenuse. First, I'm going to find the cosine of 30, because cosine of 30 is your x value. So cosine of 30, that's adjacent, which is x squared to 3, over hypotenuse, which is 2x. The x's cancel, and I'm left with square root of 3 over 2. So that means that point right there is square root of 3 over 2. That's how far over on the x-axis we went, with square root of 3 over 2. And then we can find the sine of 30 to get the y value. So sine of 30 is x over 2x. Those cancel, and you get 1/2. So that means the y value there is 1/2. Okay. And then let's go back to like 7th grade. You remember learning like reflections and stuff. And if you reflect over the y-axis, your x values become negative. If you reflect over the x-axis, your y values become negative. So that's what we're going to use here, because I can reflect that point into each of these quadrants. So in the first quadrant, let's just write some things real fast. The first quadrant, the x value is positive, the y value is positive. Everything's positive there. In the second quadrant, the x value is negative, but the y value is positive. The third quadrant, the x value is negative and the y value is negative. In the fourth quadrant, the x value is positive and the y value is negative. Okay, so if I reflect this, I can reflect that over there. It's the same exact point. It's the same exact distance from the origin, but my x value there is negative. So it's a negative square root of 3 over 2 and a positive 1/2. That same point can reflect down, and that becomes their same exact distance from the origin, but they're both negative now. And then you could either reflect this point back over here, or you could just reflect this point down. Either way, it's the same thing, but now our y value is negative, so it would be square root of 3 over 2 and negative 1/2. Okay, let's look at this one. So 45, 45, 90, we're using another triangle, so that's going to be x, x, and x squared to 2. So first I'm going to find the cosine of 45, which is going to be adjacent over hypotenuse. So we can label our sides. The adjacent side is x, the hypotenuse is x squared to 2. They cancel, you get 1 over the square root of 2. There's that weird thing in math where they don't like square roots in the denominator. So we're going to rationalize it, multiply by the square root of 2 to top and bottom. You end up with the square root of 2 over the square root of 4, which the square root of 4 is 2. So that ends up being the square root of 2 over 2. So that point right there is square root of 2 over 2. Okay. And then for the sine, notice how we're starting at the same exact thing that we did right here. Same thing, which means we're going to end at the same point. So that means that the sine value is also square root of 2 over 2, which makes sense because these lengths are the same. So it makes sense for both of these points to be the same. Okay, so that's also square root of 2 over 2. Then we can do the same thing, reflect it. So we reflect it there. It's negative square root of 2 and positive square root of 2. Reflect it down. They're both negative. And then the last one in the fourth quadrant, just the y value is negative. Okay, last one. So now we're going to use the 30, 60, 90 triangle again, but now the 60 degrees is the angle we're working from. So opposite of 60 is x squared to 3, opposite of 30 is x, hypotenuse is 2x. So cosine of 60 is x over 2x, which is 1/2. So that is 1/2. Sine of 60 is x squared to 3 over 2x, which is the square root of 3 over 2. Notice that these are just switched of each other. Okay, all we did was we took this and flip-flopped it. Okay, there's tons of patterns here. If you can start to recognize patterns, you will start to get the unit circle down a lot quicker. Okay, and again, this can reflect. So it goes there and it's the x value is negative. Down there, both negative. And then down to the fourth quadrant, just the y value is negative. Okay, so now we have all the points. So if you can get all the points in the first quadrant, you can fill out this entire circle. Okay, and it's nice because since it's a circle, that means they're all the same distance from the origin. It's just figuring out what they are. Okay, the last thing is positive, negative stuff. So if you remember that all students take calculus. Now I know not all students take calculus. You could say all students take chemistry. I never took chemistry, so that's not true. But whatever you want to come up with. But this tells us what's positive. So everything is positive in the first quadrant. So sine, cosine, tangent's positive. Students, sine is the only thing positive in the second quadrant, which means cosine and tangent are negative. Take, tangent is positive, which means sine and cosine are negative. Calculus, cosine is positive, which means sine and tangent are negative. Okay, and that's the circle. Okay, yeah, I'm not sure. I'm not singing this. Sokotoa, what a wonderful phrase. Blah, 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 blah. You can sing that if you want. But basically, this is your circle. This is, yeah, cool. So I hope you're all doing awesome. I miss teaching. Bye.